next we have a talk from Willem. Let me just quickly check something. Yep. So hi, Jan. I first met Jan when I attended a talk he was giving, and I remember very distinctly that I was being awe-inspired by his data visualization designs. I find his work specifically very relevant to the world we are living in today because data is abundant and everywhere, but it's not always easy for everyone to make sense of it. And Jan's visualizations bridges that gap very nicely and democratizes data. He's also working on an upcoming online class on the art of data visualization design. So follow him to be updated about the class and when that's available if you're interested. Today, he's taking us through his process. The floor is yours.
Thank you. Let me make my screen big. So you see everything? So yeah, my name is Willem TULP. I'm a data experience designer and I create creative data visualizations. And today I want to talk about from data to visualization with intent. And I want to start with a bar chart because I think what I'm going to tell about creative data visualization, it does not necessarily mean that a bar chart does not have intent. I think the designer of this bar chart has made clear decisions about which data to show, how to show it, the ordering of the values, titles, and things like that. So there's definitely intent here. And a bar chart works really well because we as humans, we are very good at seeing the differences in lengths of the rectangles in this case. So it's very effective. And if you would break down this bar chart, you would see on the vertical axis, you would see country labels. So that's a categorical scale. And you have on the horizontal axis, you have the expression of, in this case, the value for life expectancy represented by the length of the bar. So we have one quantitative value dimension, the life expectancy, and one categorical value. And that's basically the recipe for a bar chart. So every time you run into a situation where you need one categorical value and one quantitative value, you can create a bar chart. So this is actually all good news because you have many situations where this is the case, and also it's a very effective way of showing data. And since people are using this all the time, people are very familiar with it. So it's all good, actually. So I don't have any complaints about a bar chart in that sense. However, at the same time, the downside is that everybody uses them and they all look the same. And maybe you don't remember a specific bar chart because they all look the same, or you were not that engaged with a bar chart. Because they all look the same and it's kind of a single recipe for all situations. Another thing that it doesn't really do is, because it works for all situations, it's not specific for a particular situation. So it doesn't tell you anything about the ideas behind the data that it shows. And that's basically what I think is creative data visualization design. So it's not just looking at what data types do I have. Do I have categorical, quantitative, or ordinal data dimensions in my data set? And how can I map that to visual properties? That's already a very good thing. But I think creative data visualization design, when you do that, you try to think a little bit further than that. And that's what I'm going to show today. Because as mentioned, I'm working on an online course, the art of creative data visualization design. And I must say that it has been quite a challenge for me because I've been doing this work for almost 10 years now, and it's really intuitive for me. And I keep lots of things in my mind while working on visualization projects. So what I've been trying to do is write down all the things that I well, all the questions that I ask myself and all the things that I do, and I try to turn that into some kind of framework. And that framework is the thing that I would like to share with you, because I think it's interesting, even if you're not in the course. So what you see right here is, I think, kind of a general communication model. If you want to communicate something, you might create a communication artifact or design, and then there's an audience and they interpret your design. And this communication artifact can be anything. It can be a song, a painting, a news item, an advertisement, website, anything, graphic design. It's just the thing that you use to communicate something. Now, when you actually make a design, it's usually a very good thing not only to create it, but also to take a step back and try to pretend you're your target audience. And look at your design and see what it means. And does it really communicate the thing that you have in mind? Does it facilitate the type of interpretation that you have in mind? And or are there things that don't work really well? Do they need improvement? So besides skills of showing data, you also need skills of seeing data in your design. There's another reason why this is very important, because you can do user testing, of course, but in my experience, creating a data visualization is a very evolutionary process. In the beginning, you usually do not know what the end result will be. So you constantly improve your design. And I think it's not very efficient and realistic to expect that there's someone right beside you and judging your design for every step. So you have to have this skill yourself as well. And there's another reason for some public-facing projects, there may not even be your target user or target audience available for testing. So I've done quite a few projects where, of course, there are maybe a client or a scientist who knows about the data, or other people who know, who can have a say about it. But I've done quite a few projects where I didn't do any testing with the end user, simply because, well, sometimes you work on a project and you don't want to reveal it yet, or things like that. So it's quite common to not do any actual user testing with end users. So the first thing is every project has a context. And with that, I mean constraints and requirements. And you might say that requirements could be considered constraints as well, but kind of self-imposed constraints. If you have a requirement at a high abstraction level, you can think of the goal of a project. Something like, we want you to design something where users can learn about this topic, or something like that. That's a high-level goal. Sometimes it can also be very specific. We want you to create a visualization, and it needs to be shown on our corporate website. So the colors that you use have to be as much as possible from our corporate design style. That's a very specific requirement. And there are also constraints, like we want you to create a visualization and it's going to be on print. Now, that, for instance, means that you probably will not consider interactivity. You might maybe consider folding paper or doing something creative with that. But I think for most situations, when you create something for print, interactivity is, for instance, out of the question. So the general context of your project already gives you, well, at least some general direction and sometimes some specific details of what you should be doing. Then the next thing is the data itself. And yeah, there always has to be data for a data visualization. There's no data visualization without data. And data is something I think is quite special, because we as humans, we can navigate the world around us. We can manipulate it, interact with it. But we can only do that within the world directly around us. But there are lots of things that are too big or too small, too fast or invisible or abstract concepts. And those are things we cannot experience or perceive. So what we then do is we collect data about this so that we can, in a kind of an indirect way, enjoy or experience or learn from things that we otherwise would not be able to do. So when I think of data, I think of something like this. You're having dinner with a friend of yours and you take a picture of your food. This picture is the actual data point, but the food in front of you is the real world. And those are two completely different things. This picture is really a moment in time from a certain angle with a certain lighting, and that's it. But the food, you can taste it, you can smell it, you can move it, you can touch it, you can eat it, you can leave it there, and then it changes. So these are completely different things. If that would be a data point, this would be a data set. And here you might say, this is a guy doing a backflip. But if you look closely, it's actually not a guy doing a backflip. It's multiple pictures of a guy doing a backflip. And that's basically how data sets work. So we have not just one data point, but we have lots of data points. And by combining them, we try to look for trends or structure or patterns or things like that. But you have to realize, just with the picture of your food, in this picture, there are also a lot of decisions involved. So who's the model going to be? How many pictures am I going to take? What's the lighting going to be? What's my position going to be? And this is true for every data set. The data set is always a simplified abstraction of the real world, where there are always decisions, maybe conscious, maybe unconscious, but there are always decisions involved. And this means that your data is kind of a limited representation of the world around us. And one thing that I think is not sometimes considered, but not often enough, let's put it that way, is what I would call non-data. Because your data represents something, but this something is more than is being captured with your data. And it's not metadata, which is data about data, but non-data is kind of properties and concepts and ideas about the topic that your data is about. So for instance, if you have a data set that is about the number of trees planted in a year or something, your data set might have a column with a number for each month or each location, and that's the number of trees planted. And that's what is in your data set. But what's not in your data set is that it's about trees. Trees are living things. They grow, they die, they have branches, they change during seasons, the leaves are green. These are all kinds of properties about the thing that you are visualizing that is not part of your data, but could be something that could influence your design. And that is where you might see some designs where they use visual metaphors, and that's where that comes from. But it's not only for used for visual representation. It might also be something that you could use to structure your data, or the way that you explain your data or something. It is really important to consider non-data as well. And here's an example project. I hope that you can see the video. This is a side project I did a few years ago, and it's a representation of 24 hours of train data in the Netherlands. Now, what you see is that the cities are constantly moving. The orange dots are trains moving between cities, but the white dots are cities, and they move. Now, the thing is that this visualization is based, the entire concept is based on non-data, because I had this idea that I was thinking about, so what does it mean if a train moves from one city to another city? And the idea that I had was, conceptually, it moves one city closer to another city. And I don't know if this makes sense or not, maybe not at all, but at least it was the concept I was working with. And that was the concept I also implemented. So cities actually move closer on the screen when there are trains moving between cities. And since there are multiple trains leaving from a city at a certain moment, so cities move all around. And I would expect that during the day, the west of the Netherlands, where there are much more trains, would contract, and then in the evening they would open up again. And that's kind of what happens. And it's also, I would say, valuable to do these kind of experimental projects because, yeah, obviously it's a side project. There's no real client and a real goal for this project. It was just a fun idea I wanted to explore, but it led to another project which I will show later. And it's also currently part of the permanent exhibition of Ars Electronica in Austria. So doing these kind of side projects where you do creative experiments is highly recommended, I would say. There's another thing that has an influence on your design, and that's your audience. And it's not, your audience is, of course, interpreting your design. And an obvious thing is to consider is what is the data literacy of your audience and what is the visual literacy of your audience. And that might mean that you might need to provide a certain level of guidance to guide your audience through visualization. That is one thing, and that's maybe should be obvious, I would say. But there's another thing, and that is your audience are humans. And humans are good at some things and not so good at other things. And if you look at data, sometimes in your data you see that there are big numbers. And one thing that people don't have an intuitive sense of is big numbers. And if you look around on the internet, you see that designers sometimes translate big numbers to different kind of concepts or units. So 1,000 kilometers, how many soccer fields is that, or something like that? So that, well, you can imagine a soccer field, so then you should be able to imagine 1,000 kilometers or something like that. So translating units to something that is more intuitive is one thing that you could do. And that's another example. This is, again, a side project I did at the end of last year. And it's called COVID spreading rates. I took this screen recording this morning, and it's based on data from Our World in Data. And when I created it, it was just countries, but apparently they also included a region, so it's not entirely correct anymore. But anyway, the reason behind this project was that by the end of last year, the focus was more on the number of new cases instead of vaccinations, which is the current focus more, at least in Western countries. And I would say that in all the news outlets, you would see there are 500 new cases in this country, 200 in that one, 1,500 in that one, etc. So, of course, you can say, well, that country has much more than that country, and even, well, 100 cases, 200 cases. You can rationally compare those numbers, but do you have a feeling with how much more is 200 compared to 100, or 1,500 to 2,000? How does it really compare? Do you have a sense of it? Yeah, you can say one is more than the other, but how much more? And so what I did right here is I translated these big numbers to the number of cases per second. And so basically what I did, I created a kind of real-time simulation. And so in real time, you see how many new cases there are in each country. And so the visualization itself is not very revolutionary. It's kind of a radial progress bar or something. But the idea to show data per second, that is a really different approach to showing how many new cases are reported every second. And so you can really get a sense of, now there's a new case, now there's another one, now there's another one, and for that other country it could be now. And that's something you can experience right now. And so these types of visualization where they try to turn concepts or data into something you can experience directly, yeah, it's what I would call direct experience type of visualization. And this would be one example of it. The final component of this framework is you. Obviously, you are creating the design. So yeah, just like with data, you are already present in the design because you make all the decisions on what to show, which data to show, etc. So you're already part of it. But there's more that could be part of the design. Because maybe you have an opinion about your design. Maybe you have want to make an argument, or maybe you have some some emotional ideas about it. Maybe you think it's a very sad story. So would a bar chart with blue bars, just like every other bar chart, communicate the fact that you find this a sad story? Probably not. So maybe you have to come up with another way to communicate the fact that this is a sad story. So again, it also makes it more relatable, but it also involves including your own ideas. And it can also include having your own ideas with regards to design. Sometimes you have the opportunity, if the constraints of your project allow this, to come up with well, really creative approaches of showing data. And that is the project that I want to show next. And this is the follow-up project of the first project that I showed. And this is for the Dutch railways. And it's, again, 24 hours of train data in the Netherlands. And here you can select a country, or a city, I mean, and then you see all the trains that that pass that city at a certain moment in time during the day. And what's happening is that when a train moves, it leaves a trail. Now, if you would consider this to be a two-dimensional map, you could think of it leaves a two-dimensional trail, so it leaves the track. But in this case, the time is moving as well. So it leaves the trace, but the time is moving in a circle. And it's moving in a circle because it's 24 hours, it's a day, and after that it starts repeating itself. So this circle concept makes sense. So when you see the map, you see all the cities, and you see the trail each train leaves behind the map. And then you can switch to the 24-hour view, and then you see 24 hours of train data. And in this case, the color represents how busy it is. And so every city has its own kind of unique characteristic or shape, or whatever you want to call it. And now in this project, I was able to create a design like this because the idea was that this was used on the website where they published the annual report. And the idea is annual reports are boring. So they thought, well, maybe we should create something that is a little bit more engaging so that people would enjoy at least coming to this website. And that's the purpose of this visualization. So I was given quite a bit of freedom to come up with my own approach. And as you can see, it still communicates some data, but it's not like a tool where you can make serious decisions. Really the purpose is to create something that people can play around with and be excited and see data from a different perspective that they maybe haven't seen before. So that's my basic model, and yeah, obviously in my course we will do a deep dive of this model, but this is basically the foundation, the three main concepts, the audience, the data, and the non-data, and you, and how they influence the design. And ultimately what I try to do here is to learn people about the thinking process behind these creative visualizations. And I think these are the main components that help you think about creative data visualizations. So, and with that, I would like to thank you very much.
Thank you very much for sharing your designs and your framework with us. I'm gonna go through the questions. So the first one is from Carla. And I think they're referring to your COVID visualization. They're asking, why is this info presented in donuts and not in bar charts? Usually bars are easier to compare.
I don't know. It's I was more thinking of progress bar, and yeah, you could do that. I thought visually it looked a little bit more appealing. It's also keeping in mind what you want to do with this visualization. My idea was to give people kind of a different look on data they're familiar with. And is it really important that they can make an exact comparison? There's also a description of each rate below each circle. So yeah, it's absolutely true. Bars are probably easier to compare. then again, I would say that sometimes that's the fun part of creative data visualization. Sometimes it's not just about creating effective visualizations only. It's also about creating something, well, my own opinion, or something that I think looks nice, or and so it's really finding this balance, because you can, of course, you can also map your data to very expressive and obscure forms. It could still work, and the idea is still the same, but it's this balance that you need to find, where you try to find something that looks nice, but people can still get a sense out of it. But yeah, obviously, if this would be a tool for users to make serious decisions on a daily basis, yeah, I would probably have chosen bar charts, but that was not my target audience in this case. So.
That's actually a nice bridge to another question. So how do you find balance in the value of aesthetic design and a more direct and efficient way of data visualization? So you partly answered that, but anything to add?
Yeah, it's a good question, and I don't have a straightforward answer to that, other than, yeah, when you create a design, there are many things that you have to take into account, like who's going to use it. So is it going to be a tool, or is it going to be something that people are going to look at for 2 seconds and then go on to the next thing? Is it going to be used internally? Yeah, there are so many things, and sometimes there's a situation where you have, yeah, it makes sense to have more freedom to how you create, well, incorporate more aesthetic designs, and in other situations it is more, well, straightforward and purely about effectiveness. I think for me, I would say that most of my projects are focused on communicating something to at least a broader audience. And I would say that for most of those projects, it's not a situation where people are making serious decisions based on my visualization, but they want to be informed or entertained or something like that, or be surprised by a new look on data or something like that. And so usually I would say that, although there's some variation, but for many of my projects, I try to find kind of a middle ground. So they do inform to some extent, but it's not purely about effectiveness only, but also about creating something that looks nice.
And another question is, do you advise designers to be, like, I'm guessing designers that are working on data visualization specifically, to be data scientists as well? And if so, what do you think is the best starting point?
I don't know. It really depends. I'm not a data scientist myself, so and I do create data visualizations. I think, well, the thing about data visualizations, at least the way that I create them, is I create them using coding, programming. So for me, it means you have to know how to code, and you have to know something about data, and you have to know something about design and usability. So for me, that's what makes it really exciting, because you have to know about a lot of things. Yeah, but it's not really necessary especially today. There are also quite a bit of tools that allow you to do pretty creative things. There's, for instance, a tool called Flourish, and there they have design templates which you can modify yourself. So if you know a little bit of programming, you can create very creative designs. So today there are quite a few options to create designs without programming knowledge and without knowing too much about data. On the other hand, if you do create data visualization or work with data, it would make sense to be at least a little bit knowledgeable about data and what makes sense and how to work and deal with it.
Yeah. And another question is, would you recommend some visualization coding frameworks or libraries that you like to use?
I would say that for all my projects, I use D3. That is, I think, the most used framework for data visualization. But I use that primarily for all the utility functions. For more complex visualizations, you you often have a situation where, yeah, things become so complex that you need to manage the complexity in some way. So for quite some time, I've been using some standard web frameworks as well. And the one that I've been using for the past 3 years, I think, is Svelte, which is a new web framework. It's just a general web framework, but it's a very good match for data visualization, and more data visualization creators are moving towards using Svelte as well. And for me, those are the two that I use all the time. I sometimes use, if I need to do data processing, I use Python for that. Other than that, it really depends on the project. So if I do some things with three-dimensional things, then I use 3JS, which is my favorite library for that. But yeah, other than that, it just depends on the project, what I need.
And do you have some tips on how to make interactive visualizations work on mobile as well, looking at performance?
Well, I think for mobile there's performance. I'm not sure if that is necessarily the biggest challenge, actually, because especially modern phones, they're quite performant. So if it works on your desktop or your laptop, then it will probably work on your mobile phone as well with regards to performance. So for instance, I've done a project for the European Space Agency where I simulate 60,000 stars in the browser. And that performs also quite well on my phone. So that's not really the issue, I think. What's more of a challenge, I would say, is that you are dealing with a much smaller space. And so you have to decide, how am I going to deal with a situation where on a big screen I can show a lot, and on a small screen there's much less space available. So am I going to scale everything? Am I going to show a reduced version or a completely alternative version? How am I going to handle a situation where on laptop or desktop you can have mouse overs, and on phones it cannot, and on the phones you have your big fingers, and on laptop you have a thick mouse. So I think interaction in that sense is more of a concern, as well as the size of your display, than performance.
And I have a question myself. So you talked about emotions in your presentation. This might be a cookie question, I'm not sure. In your experience, is there a difference between different visualization in terms of evoking certain emotions? Do you find some visualizations better suited for certain feelings?
I don't know if there are specific topics or something that are more suitable, but there's one collection I just found out, I think last week, is by Density Design in Italy. And they have a huge collection of student projects. And if you Google on data poetry, then you can find a huge collection of student projects in which all these projects are based on data, but they use an interpretive type of mapping. So if, I don't know, if it's something fragile, maybe you show flowers or something. So a flower is not an exact representation of data, but it shows the concept. And so for every project they show, they describe what the metaphor is and what their intention is. And so they're all kind of interpretive ways of mapping data to some kind of representation. And another great project, maybe you've heard of that one, is Dear Data by Stephanie Posavec and Georgia Lupi. And that's also a project in which they send postcards to each other for a year. And every week they collected data about themselves, and on the front of the postcard they drew an infographic or a visualization, and on the back they created a legend. And they did this for a year, and it became a hugely successful project. But the thing, what they did was also kind of interpretive mapping. So they did collect data, but they both don't know how to code, so they draw their designs by hand, and so not everything looks exactly the same, and sometimes it's just an idea of how data maps. And so I think, especially if you want to show something like this is bad, or this is good, or this is complex, or this is slow, or something like that, and that's more kind of a higher level message instead of specific patterns or structures or outliers or things like that. What you then can think of is more kind of interpretive ways of mapping data. So what kind of concepts would you think of when you want to communicate something like that?
Thank you so much. And again, thank you and all of our speakers for sharing your experiences, your wisdom, your designs, your research with us.